Hi everybody, welcome. I'm glad that you're here with me today. Today we're going to talk about applying all that exponent knowledge that we have and applying it to geometry problems, okay? So let's begin. Here we have this, and I hope you're following along with your own notes. We want to find the volume of a cube whose side measures negative 9kx cubed, right? Or we could say x to the third power. So I think the first thing I'm going to do is I'm going to really quickly I'm very visual, so I'm going to sketch a little picture of a cube. And if you recall, a cube is where all the sides are equal, right? Something like this. So please forgive me, my drawing's not perfection, but it's mostly just to get the idea, right? There's our cube. Okay, so now all the sides are equal, and guess what? One side actually measures this. So I'm going to go ahead and label my drawing, and I've got negative 9kx to the third. So basically we're just going to plug it in. Find the volume. That's what V's for. And we're going to leave that empty, put the little 3, and inside we plug in negative 9kx to the third. Okay? So whenever I need to refresh my brain as far as like what rule to use when, okay, I just look at my little star sheet. This is going to be a really helpful tool. Let's keep in mind that we have two exponents right next to each other with a parenthesis in between, and this exponent does not have its own base. So let's go over here, because you will have access to this on your star exam, so I strongly recommend that we reference it. So here, no parentheses, boom, we have a parentheses with two exponents right next to each other. That's exactly what we do. And we take the two exponents, and according to this, we multiply, right? Do you see how m times n, when there's nothing in between, we assume it's multiplication? So this is the power of a power. Let's go back and let's apply it, okay? So when we do this, it's going to end up being negative 9. And then if you don't have an exponent, you can put a 1, right? I'm just going to kind of spread this out a little bit. I got an exponent of 1. And then here I have an exponent of 3, right? And what I'm going to do is I'm going to distribute that exponent to each one. Okay, so it's going to get distributed here. And the most common mistake is that students will forget to distribute it here, and then they forget to distribute it even to the coefficient. So we want to make sure that we do that. So that's times 3, and then times 3. Okay, and so we end up with negative 9 to the third power. K, because that's 1 times 3 to the third power. And then 3 times 3 is just 9, right? So you may see the answer like this on your test. I kind of doubt it. I think what they're going to do is actually simplify this a little further, so we can actually put that in. Let me warn you that when you enter it, if you enter it like this, the calculator will straight up lie to you. Okay? And I hit caret and then 3. Okay? Does anybody know what I did wrong? If you said that you need to put parentheses around the negative 9 first, you're absolutely correct. Make sure that whenever you have a negative base, that you surround it with parentheses and then put it to the power of 3. Now, it really didn't make a hill of beans this time. But had it been like a 2 or a 4, your exponent with an even number, it would have made a difference, okay? So sometimes, so I'm just saying, just to be on the safe side, put parentheses around there. So we end up with negative 729 k to the third power and x to the 9th power as our final answer. Okay. All right. Let's go right here to the next one. This one is super duper important. If I was to understand one of these 4 here, this would be the one. You are going to see this. Hint, hint. Okay. So which expression describes the area in square units of a rectangle that has a width of 8m to the third power, all of that squared, and a length of 4x squared m to the 4th, right? We're going to use this formula. Not a bad idea for you to remember these formulas, right, from middle school. So let's go ahead and let's just write the formula. And we're going to plug everything in. What is L and W doing? They're multiplying. So keep that in mind. All right. Which expression describes the area? For it has a width of, okay, so this is W right here, right? And a length of, so this right here is L equals, yes? So I'm going to go ahead, and wherever I have L, I'm going to plug in all of that. And where I have W, I'm going to plug in all of what W equals, right? So let's plug stuff in. L again is 4x to the second power m to the fourth, okay? And here I have all of that. So I'm going to write all of that. I'm going to include that. M to the third, and then to the second. Okay? So now what I want to do is I want to get all my coefficients up front. So if we look at the rule right here, okay, this is basically this product of powers. And what we're going to do with our exponents is we're going to add them because each one has their own base, right? So let's kind of organize it. This is going to be, I've got 4 times, and then I've got 8. Oh, 8. Before I can start doing that, though, I've got this I got to deal with, right? I've got to deal with that parenthesis. That is right here, that power of a power, right? And we have to distribute the n like we did on the last problem. So that was m times n. So let's go ahead and do that, okay? And glad I caught that. So let's go in here. We're going to just rewrite this. And then over here, I'm going to distribute that exponent. And I'm even going to distribute it right here. Remember, if we don't have an exponent, we put a little exponent of 1. So that's going to be 8 to the power of 1 times 2, and m to the power of 3 times 2. Okay? And so now let's go ahead and continue to kind of clean this up. We have 4 times, right? We have x to the second. We have m to the fourth. Everything's being multiplied. And then we have 8 to the second power, and then we have m to the sixth power. 3 times 2 is 6. Let's kind of further organize it. I'm going to put 4 times 8 to the second power. So I put all of my numbers, my coefficients right up front. I'm going to take everything with an x. Okay, that's just one thing. And I'm going to put that next. I usually like to go in alphabetical order, so we'll clean that up in a little bit. And then I'm going to go ahead here with my m's. And I got m to the fourth, right? That looks weird, but it is 4. Okay. M to the fourth, and then times m to the sixth, right? Okay, looks good. So let's continue cleaning it up. I got to say, this number part, I'm just going to drop it right into the calculator. 4 times 8. And I don't have to worry about putting in parentheses because it's not a negative base, right? And I'm just going to put to the second power, caret into the second power. And then I got 256. I have x squared. But you know what? I said I wanted the m's first, right? Okay, so I'm going to put the m's. Now, when each has its own base, again, we go back here, right? Each one has its own base, and we just add. So I'm going to go ahead here, and I'm going to add 4 plus 6. And then I've got the x squared. Let's continue to keep cleaning this up. 256, m to the 10th, x to the second. And ladies and gentlemen, this is our final answer. Okay. All right. Let's move to the next one. All right, number 3. Which expression describes the area in square units of a square that has a side of 3x to the third power y to the fifth units? So let's go ahead. I'm going to draw my perfect square right here. Okay. And we know that the area for a square is the side times the side, or width times length, right, when we're talking about rectangles. So what we're going to do this, if we multiply the 2, that's actually equal to 2 squared, right? So that's where they get the formula. So I'm going to go ahead and I'm going to plug it in. And they give us a value for the side. They give us 3x to the third power, y to the fifth, do it like that. And so just to refresh my brain, I got to remember, what do we do when we have that parenthesis and the 2 exponents, and this exponent doesn't have its own base? So I look down here, and the 1 with parentheses, well, that's different. So right here, see, it's got parentheses, a little n, and so we're multiplying the exponent. So that's called power of a power. So let's go ahead and let's do that. We're going to go ahead and put in any little hiding exponents of 1. So I'm going to put one right here. And we want to distribute. So that becomes 3 to the power of 1 times 2, x to the power of 3 times 2, y to the power of 5 times 2. I'm going to continue to clean this up. 3 squared, x to the 6th power, and y to the 10th. Now I'm going to toss that in my calculator. You can put it in your brain too. That works. Whoops. And I'm going to go ahead and 3 to the 2nd power, and we're looking at 9. And so that is 9x to the 6th power, y to the 10th is the area of our little square. Okay. If you have any questions, make sure that you do bring it to your teacher during sync time. And let's go ahead and let's focus on our last type today, number 4. Here we have a circle with a radius. And y'all know radius goes from the center of the circle to the edge. So the circle has a radius of 4x to the 6th power, y to the 3rd centimeters. And the area of a circle can be found using this formula right here. A is equal to pi r squared. What is the area of this circle in square centimeters? Okay. So when we do this, let's go ahead and start with our formula. A is equal to, and we have pi, and we actually know what r is. This says radius of. It's another way of saying r equals, and r equals that good stuff. So I'm going to go ahead and put parentheses right here. And I'm going to toss in everything that r is equal to. So r is equal to 4, x to the 6th power, y to the 3rd. Okay? So just like we did last time, we kind of looked, what do I have to do? That's power of power, right? So we're going to go ahead. I'm going to put in my little hiding exponent right here of 1. And I'm going to distribute and multiply times each and every one, right? So let's go. Write this out. A is equal to pi. We're going to pretend that's a pi. And then times 4 to the power of 1 times 2, x to the power of 6 times 2, and y to the power of 3 times 2. Okay, let's clean it up a little bit. Get a better looking pi there. Times 4 to the power of 2, x to the power of 12, and y to the power of 6. Okay, I like them in alpha order, so that's pretty good. And I'm going to share with you 2 ways that you may see the answer, okay? If your answer on your exam includes pi in the answer, then what you want to do is just simplify your coefficients. I'm going to go to my calculator. 4 to the power of 2, 4 times 4 is 16. And I'm going to write down 16 pi x to the 12th power, y to the 6th. Now that could be one answer choice if your answer has pi in it. If it does not have pi and they just want like a straight decimal answer, then what you could do is actually take this part right here, the 16 pi, put that in your calculator, 16 times, and then pi is located, let's see, I should have looked this up before. See right here where you have that caret, right, that you hit for exponents? Well, it's in blue on mine, so I want to hit the blue button, second, and then the little caret, and I get my pi, okay? Please do that instead of 3.14 because it is way more accurate. And then you hit enter. And does it tell us what we can round to? Nope. So I'm just going to round to the nearest hundredth. Okay, 5 or more, raise the score, right? So 50.27 approximately, right? I'm going to make this approximately. That's really awful looking, but anyway. And then x to the 12th power, y to the 6th. And so these are essentially equivalent answers, okay? I'm going to put approximately equal, okay? So thank you so much for being with me today. I think the major one, if I had to point out, major one that you would definitely understand is number 2 with calculating a rectangle with for area with width and length. That would be one that would be essential. If you have any questions, make sure that you bring it to your teacher. And again, thank you so much for spending time with me today. Y'all take care. Bye.